All right. Guys, take a look at this diagram. This is another property of waves, things that waves can do that particles cannot. Some people are interested in giving back.
Oh, yeah, I know.
All right, in contrast to particles, waves can occupy the same space at the same time. This is not, particles cannot do that. So waves can occupy the same space at the same time. They can pass right through each other. So particles, when they collide, raise your hand, you've been in a car accident. When those cars collide, their kinetic energy is completely destroyed, right? It's gone into heat, it's gone into sound deformation. The energy is changed. When waves collide, they interfere with each other and they pass through with unchanged. Now, based on conversations I had with other classes, they had not heard of different kinds of interference. So I'm assuming you guys haven't either. So I'm going to go through these kinds of interferences here. This is a crest that's meeting with a trough. So I'm going to use color coding for us to be able to see that. So there's a crest, here's a trough. When they overlap, those overlap right here, what we notice is that these two things sort of cancel each other out just when they overlap. For the time being, that rope is stationary. And then after they pass, the red continues on unchanged, and the blue continues on unchanged. That kind of interference is called destructive interference. So these things are, for a moment, destructively interfering. So if you hadn't heard of that before, and most kids had not, that'd be a good term to put down. Destructive interference. A cancellation momentarily. Now, if this is destructive interference, what happens if I have a crest hitting a crest? What kind of interference would you say that is? That is constructive. Thank you for that. That was loud enough that the video recording even picked that up. I don't know who said it, but you are absolutely correct. I appreciate that. These two waveforms will coincide and constructively interfere. Then, of course, after they get through each other, they continue on unchanged. And so this would be called constructive. Now, my question for you is, which kind of interference do noise-canceling headphones rely upon? Disruptive. Raise your hand. You've heard of noise-canceling headphones. You've heard of them. Some of you may even have them. How do they work? This is an exam question. Describe how noise-canceling headphones work. This is a question on your exam. They take advantage of destructive interference. So what noise-canceling headphones do is they sample the ambient noise. You guys remember when we were doing the speaker thing? We're like, hey guys, quiet, quiet. Ambient noise disrupts the sound level that we're trying to listen to. So what noise-canceling headphones do is they sample the noise. It has its own signature. They invert it using electronics. They take that wave, they make the opposite of it, and then they feed that to the speakers, and it cancels out the noise. How does adding sound to something make it quieter? By destructively interfering. Noise-canceling headphones take advantage of destructive interference. You ever been surfing? Water waves will often constructively interfere, and as a matter of fact, there are different kinds of waves that are coming in from the out in the oceans or out in the lakes. They have different wavelengths, they have different speeds. At times, they coalesce and they create a really big wave. That's the one that you ride on, and that has to do with constructive interference. So waves can do that, particles cannot. Now, I don't have a whole lot of time to go through this thing called the superposition principle, but I want to describe really quick what it does. Superposition is describing what happens to the waves when they coincide. They basically add or subtract depending on whether or not they're above or below the equilibrium position. Gavin, what time did you say it was? 49? Okay. Would you guys agree that this is the equilibrium position right there? That's equilibrium. These are square waves that are common in computer systems. This could be a 1. this would be a 2. When they overlap, they would add to be a 3. That would be constructive interference. If this is a 1, this would be a negative 3 relative to the equilibrium position. That's right here. When they overlap, it would turn into a what? Negative 2. Just for the time being, then they pass through. That's the tricky one. Now I have a square wave that has both a crest and a trough overlapping with something that's just a crest. When these things overlap, this is a 2, that's a negative 2. This is a 1, that's a 1. The 2 and the 1 will be over top of each other. At the same time as the negative 2 will be over top of that, and that waveform would look like that, just for the time being. And then they pass through each other. Waves can coexist, superimpose. Particles destroy each other. Waves combine through interference. I'm going to stop there, folks. Your OMI homework